Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 27, Multi-Tenant Data Isolation. Alice, this feels like one of the highest stakes topics in the whole series. If your SaaS stores data for 50 law firms and firm A sees firm B's documents,
Then you don't have a bug. You have a lawsuit, a breach notification obligation, a regulatory investigation, and probably the end of your company. Multi-tenant data isolation is the architectural foundation that prevents this. Every firm's data must be completely invisible to every other firm. No exceptions, no edge cases. No. It only happens under unusual load conditions.
and this is different from the ethical walls we covered in episode 25.
Right. Ethical walls are intra-tenant, within a single firm. Partner A can't see partner B's conflicting matter. Multi-tenancy is inter-tenant, between different firms entirely. And it's a different technical problem. With ethical walls, both users are in the same firm with the same general access rights, and you're carving out specific exceptions. With multi-tenancy, the two firms should have no awareness that the other exists. Their data should be as separate as if they were on different planets.
Right. So what are the options architecturally?
Three main models. First, a shared database with row-level security. The pool model. All firms' data lives in the same database tables. Every row has a tenant ID column that identifies which firm it belongs to. Every query must include a filter for the current tenant's ID. PostgreSQL row-level security, which we covered in episode 8, can enforce this at the database engine level. Even if your application code forgets the tenant filter on a query, the database itself will only return rows belonging to the current tenant.
That sounds like a safety net for developer mistakes.
It is. And it's essential, because developer mistakes are exactly how cross-tenant data leaks happen. Someone writes a new report query, forgets the where tenant ID clause, and suddenly the report pulls data from all tenants. Row-level security catches that. The policy runs at the database engine level, below your application code. It's defense in depth. The concept from episode 4.
Yeah. What's the second model?
Schema per tenant, the bridge model. Each firm gets its own database schema within a shared database instance. Firm A's tables are in schema. Firm A, Firm B's in schema, Firm B. The data is logically separated. It's stronger isolation than shared tables because there's no possibility of a missing where clause exposing other tenants. The tables literally exist in different namespaces. But it adds operational overhead. Every database migration has to apply to every schema. Connection pool management gets complex, and costs scale with tenant count.
And the third.
Database per tenant, the silo model. Each firm gets its own dedicated database instance, completely separate infrastructure. Firm A connects to one database server, Firm B to another. This is the strongest isolation you can get. There are no shared resources at all. Independent backups, independent performance, independent everything.
But that must be expensive.
It is. The silo model costs the most and has the highest operational complexity. But here's the thing. Many enterprise law firm clients will contractually require it. When a large firm's security team evaluates your platform, and their RFP says dedicated database instance, they mean it. Your insurers want certainty that a bug in your application code cannot expose their data to another firm. For these clients, the cost of the silo model is built into the contract price.
Right. So which model should you choose?
It depends on your stage and your clients. Early stage SaaS with many small firms. The pool model with row-level security is cost-effective and secure enough if you implement RLS correctly. Mid-tier with moderate customization needs, schema per tenant. Enterprise clients with strict compliance requirements, database per tenant. Many platforms start with the pool model and offer the silo model as a premium tier for enterprise clients.
You mentioned defense in depth. What does that look like for multi-tenancy specifically?
It means not relying on any single layer. Your application code scopes every query by tenant ID. That's the first layer. Your alarm or query builder has middleware that automatically injects the tenant filter. That's the second layer, catching queries where developers forgot. PostgreSQL RLS is the third layer, catching anything the first two missed. And then, this is the one most teams skip, automated cross-tenant access tests in your CI pipeline. Tests that explicitly try to access tenant B's data while authenticated as tenant A and verify it fails. If you don't test it, you don't know it works.
Yeah. What about background jobs, like scheduled reports or email notifications?
That's the most common source of multi-tenancy bugs. A background job runs outside a user request context. There's no JWT token, no session, just a job processor picking tasks off a queue. If the job doesn't explicitly set the tenant context before accessing data, it may default to no tenant filter. And then the report includes data from all tenants. Every background job must carry the tenant ID from the originating request and set it explicitly before any data access.
Ugh, the Snowflake breach from 2024. Is that relevant here?
Very relevant, but not in the way most people think. Snowflake's core infrastructure was never compromised. The attackers used stolen credentials, from info stealer malware dating back years, to log into individual Snowflake accounts. Over 165 organizations were affected. AT&T, Ticketmaster, Santander. The critical detail: the compromised accounts didn't have MFA enabled. A valid username and password was all it took.
Right. So even with perfect data isolation, a compromised account is still a compromised account.
Exactly. Multi-tenant isolation protects firm A from firm B, but it doesn't protect firm A from an attacker who has firm A's credentials. That's why isolation has to work together with strong authentication. MFA from episode 21, SSO from episode 22. And it's why your platform should enforce baseline security requirements across all tenants. If you let a tenant opt out of MFA, that's the tenant that gets breached.
Let me see if I can put the full picture together. Multi-tenant isolation keeps firms separate. Ethical walls keep matters separate within a firm. Matter scoping ensures users only access their assigned matters, and RBAC controls what actions they can take. 4 layers, each independent.
That's exactly right. And independence is the key word. A bug in ethical wall enforcement should never compromise multi-tenant isolation. A misconfigured role should never expose data across tenants. Each layer must stand on its own. That's defense in depth. Not just multiple checks, but multiple independent checks.
Next episode, encryption at rest versus in transit. How you protect data, whether it's sitting on a disk or moving between services.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.